Welcome to lesson 7.6, apply the sine and cosine ratio. So in 7.5, we looked at the tangent ratio, which dealt with the ratio of the leg opposite over the leg adjacent. Now today, we are looking at the two other commonly used, I would say, two other commonly used ratios related to right triangles. So again, we need to establish that we are dealing with a right triangle. So for our examples for sine and cosine ratios, we'll be looking at the right triangle ABC here. And for both examples, we're going to use angle A. So we'll be looking at the leg opposite, the leg adjacent, and then we also have the hypotenuse. What you want to keep in mind again, in any right triangle, the hypotenuse is the longest side, and it's always opposite your 90-degree angle. So the sine, spelled S-I-N-E, but written as sine, S-I-N. So the sine of A is the ratio of the length of the leg opposite A over the length of the hypotenuse. So if we're looking at our example, that would be side BC over our hypotenuse of side AB. So what you want to remember for sine is opposite over hypotenuse. Then for cosine, so cosine, written as C-O-S-A, is the length of the leg adjacent to A over the length of the hypotenuse. So in this example, it would be side CA over our hypotenuse of BA. So our ratio for cosine is always the side adjacent over the hypotenuse. So establishing the sine ratio, we'll be looking at finding the sine of S and the sine of R. So the sine of S will be our side opposite of angle S over our hypotenuse. So the side opposite angle S is RT, our hypotenuse is SR. So opposite over hypotenuse, 63 over 65, which is approximately 0.9692. Then we have the sine of R, which would be the side opposite of angle R over the hypotenuse. So side ST over SR. So 16 over 65, which is approximately 0.2462. In example 2, they'd like us to find the sine of x and the sine of y, and then to write each answer as a fraction and as a decimal, round to 4 decimal places if necessary. So again, for the sine, we always want to keep in mind opposite over hypotenuse. So our sine of x, side opposite over hypotenuse, 8 over 17. For y, we would have the sine of y, which is 15 over 17. And you can see the decimals right there. Again, to get the decimals, simply top divided by bottom. Then in example 2, the sine of x, opposite over hypotenuse. So 15 over 25, which simplifies to 3/5 or 0.6, 6/10. And then we have the sine of y, which is 20 over 25, which simplifies to 4/5, which is 0.8 or 8/10. Then example 3 is applying the cosine ratio. So again, cosine is our side adjacent over the hypotenuse. So the cosine of u would be side uv over uw. So 18 over 30, which simplifies to 3/5 or 0.6. And then the cosine of w, which again, our side adjacent over hypotenuse, would be wv over wu. So 24 over 30 simplifies to 4 over 5 or 0.8. Now example 4, a word problem applying the sine ratio when we know an angle measure and we are trying to figure out a side length, in this case the hypotenuse. So the word problem, you want to string cable to make a dog run from two corners of a building as shown in the diagram. Write and solve a proportion using a trigonometric ratio to approximate the length of cable you will need. So you can see in the diagram that creates the right triangle with the building, our dog run being the hypotenuse, which is x. We knew the 35-degree angle, and we knew the opposite length of 11. So because we know the angle and the side opposite, and we're trying to figure out hypotenuse, we would want to use the sine ratio because that involves the opposite and the hypotenuse. If we were looking for the adjacent, or if we knew the adjacent, then we would use the cosine. So our setup, sine of 35 degrees equals 11 over x. So when we rearrange the equation to solve for x, so what we would do is multiply both sides by x, then divide both sides by the sine of 35. So that rearranges into x equals 11 over the sine of 35 degrees. So when you punch that into a calculator, you get approximately 19.2 feet. Example 5 has two parts dealing with finding the cosine r and the cosine s. So in this case, we do not know the hypotenuse. We know both legs. So in this case, if we are using cosine, we need to figure out the hypotenuse first. So the way we do that for both is we set it up in the Pythagorean theorem to solve for our hypotenuse. So to figure out SR in example 3, we have 9 squared plus 12 squared equals x squared. So 81 plus 144. Then the square root of that gives us 15. So in that case, we know SR is 15. So now we can set up our cosines. So for the cosine of r, it's going to be the adjacent over hypotenuse, so 9 over 15, which is 3/5 or 0.6. And then the cosine of s, our adjacent over hypotenuse, 12 over 15, which is 4/5 or 0.8. Then in number 4, same idea. We have to figure out SR, our hypotenuse, first. So we'll use the Pythagorean theorem. Our two legs squared equal the hypotenuse squared. So 16 squared plus 30 squared equals x squared. 256 plus 900, and then the square root gives us 34. So our hypotenuse is a length of 34. So now the cosine of r would be 30 over 34, and the cosine of s is 16 over 34. And again, to get the decimals, plug it into a calculator, top divided by bottom. Then we can apply the idea of angles of elevation and angles of depression when we are applying different ratios in right triangles. So, simple definitions here. If you're looking up at an object, the angle your line of sight makes with a horizontal line is called the angle of elevation. If you're looking down at an object, the angle your line of sight makes with a horizontal line is called the angle of depression. So elevation looking up, depression looking down. Now, the way we apply that would be in a scenario like this. So if you're skiing on a mountain and you know the mountain has an altitude of approximately 1,200 meters, and the angle of depression is 21 degrees, you can figure out the length that you went down the mountain. So we could use the sine ratio because we were given the opposite and we're looking for the hypotenuse of our right triangle. So opposite over hypotenuse. So the sine of 21 degrees is 1,200 over x. We need to solve for x. So we'll multiply x to both sides. So x times the sine of 21 equals 1,200. Divide by the sine of 21. So x is 1,200 over the sine of 21, which tells us that the length traveled is approximately 3,348.2 meters. And another way that we can apply angle of elevation or depression, in this case with a skateboard ramp, we know the angle of elevation is 26 degrees. We know the ramp length, so our hypotenuse is 14 feet. And they would like us to find both the height and the length of the base. So height, which will make x in this case. To figure out the height, we would have to use the sine ratio, our opposite over hypotenuse. So in this case, x over 14. So the sine of 26 degrees times 14 would equal x. Plug that into a calculator. 14 times sine of 26 degrees gives us approximately 6.1 feet. Then to find the base, we would use the cosine because it's the adjacent side. So the cosine of 26 degrees equals y over 14. So 14 times the cosine of 26, y is approximately 12.6 feet. Then our final example, dealing with special right triangles, which again becomes more important in Algebra 2 when you'll work with things known as a unit circle. But the idea here behind these ratios, using a special right triangle to find the sine and cosine of a 60-degree angle, and then in part B, we'll be doing that for a 30-degree angle. So I used a 30, 60, 90 triangle, obviously, because of 60 and 30-degree angles, and we have to use a right triangle. And then to set up our ratio, it goes back to the special properties of a 30, 60, 90. If we know our shorter leg is simply 1, our longer leg is the square root of 3 times that, and our hypotenuse is 2 times the shorter leg. So in this case, if our shorter leg is 1, our longer leg is the square root of 3, and our hypotenuse is 2. So in all special right triangles that are 30, 60, 90, the sine is 60 degrees, would be the square root of 3 over 2, and then the cosine of 60 degrees would be 1/2. And in part B, the sine of 30 degrees is 1/2, and the cosine of 30 degrees is the square root of 3 over 2. So really, the key for today's lesson goes back to this main idea here, that the sine is the side opposite over the hypotenuse, and the cosine is the side adjacent over the hypotenuse.